Two possibilities exist. Either we are alone in the universe or we are not. Both are equally terrifying. Arthur C. Clarke. Here's a question for you. Are there more stars in the universe or are there more grains of sand in the world? It's actually hard to answer without hesitation, isn't it? Yes, we know that there are a lot of stars in the universe, but each grain of sand on Earth must be a very serious number, right? Carl Sagan, the famous American astronomer, made this comparison in his TV program Cosmos. According to Sagan, there are more stars in the universe than there are grains of sand in the whole world. As a result of the studies of geoscientists and geographers, it is thought that the number of grains of sand on Earth is around 4 sextillions. According to calculations, the number of stars in the universe is more than twice the number of grains of sand in the entire world. When we talk about numbers, our perception starts to become vague after the units of million and billion. When we start talking about numbers like septillion, octillion, nonillion, our brains melt. According to most scientists and common theories, we are one of the countless universes floating in an infinite sea of universes outside this cosmic network at the theoretical limit of the observable universe. In such a vast universe, no neighboring civilization or living life has caught our eye. According to statistical calculations, shouldn't there be thousands and millions of environments suitable for life around us? But where are they? Or in other words, where is everyone? This question is one of the greatest paradoxes in human history and is known as the Fermi Paradox. The Fermi Paradox is the discrepancy between the high probability of extraterrestrial life, but the lack of any evidence or contact to confirm it. It's actually a simple question that we all ask or could ask. You can hear it from everybody. I mean, even a friend of ours can say, if there are aliens, why don't they come? Or why there is no trace of them? But when Enrico Fermi, a famous physicist, said this, it was recognized as a paradox. The universe is about 13 billion years old. Since the Big Bang, the universe has continued to expand rapidly. There are countless stars, planets, and galaxies in the universe. Assuming that the Earth is an ordinary planet, there is a high probability that there are living beings on other planets in the universe. The question is, why can't we prove it? Or why can't we find any trace of it? The size and age of the universe suggests that there must have been many technologically advanced civilizations. But this hypothesis is inconsistent due to the lack of observable data to support it. In 1950, Enrico Fermi argued, if there are a large number of advanced extraterrestrial civilizations within the Milky Way, why don't we find evidence of aliens, such as spacecraft or probes? Michael H. Hart published a paper on this subject in 1975, which started the debate. This paradox is also called the Fermi-Hart paradox. Another related question is the Great Silence. Even if space travel is difficult, if extraterrestrial life is widespread, shouldn't we at least hear the radio signals of these civilizations? By the way, there are opinions that this paradox does not belong to Fermi and that it is not a paradox at all. Fermi is alleged to have said this "where is everybody" to his fellow physicists over lunch, but physicists quote it differently. When the subject of extraterrestrial life comes up, there are generally two different schools of thought. One is the investigative approach based on the Drake equation, which calculates the number of civilizations in our galaxy whose signals can be detected. The other is the Fermi Paradox approach, which considers the search unnecessary, saying that if there were intelligent life, they would have already colonized the galaxy. The Drake equation is an original equation derived by Frank Drake. The Fermi Paradox is a myth, an idea that was never advocated by Enrico Fermi, the physicist after whom it is named. Either way, let us continue to pursue this question. By the way, let's talk about the Drake equation. The Drake equation is an important equation in the search for extraterrestrial life, used to calculate the number of intelligent civilizations in the Milky Way galaxy. It was first proposed by Frank Drake, a radio astronomer, in 1961. Although this equation is known as the Drake equation, scientists such as John C. Lilly, Carl Sagan, and Otto Struve contributed to its creation. According to the Drake equation, it is estimated that there are 10,000 intelligent civilizations in our galaxy. In addition to the Drake equation, a scale of possible civilizations was made with the Kardashev Scale. The Kardashev Scale is a method that measures the technological development of civilizations according to the amount of energy they can use to communicate. In 1964, Nikolai Kardashev, a Russian astrophysicist searching for extraterrestrial intelligent life through cosmic signals, introduced the idea that the civilization status of a culture generally rests on two basic things: energy and technology. He reasoned that the technical development of a civilization runs parallel to the amount of energy it can use and manage. That is, the more energy a society can produce, the more technologically advanced it is. Initially, this idea depended only on the energy available for communication, but it has since been developed and expanded. In other words, according to this theory, the development of a culture is, in the broadest sense, a product of energy and technology. Through technology, energy is obtained, and as social systems are based on this technology, the status of a culture is based on the amount of energy used. This scale has a number of different classification levels. Each is based on a level of energy consumption: Type 1, Type 2, and Type 3. Other astronomers have extended the scale to Type 4 and Type 5. These additions take into account energy access as well as the amount of information civilizations can access. In short, in recent years, scientists have extended this scale to hypothetical civilizations, galactic, intergalactic, and multicultural civilizations. Let's take a quick look at these civilization types. Type 0, Sub-universe culture. This civilization derives its energy and raw materials from organic-based sources such as wood, coal, and oil. Any rocket used by such a civilization will necessarily depend on a chemical propulsion system. Since this type of travel would be extremely slow, a civilization at this level would be mostly confined to its home planet. Type 1, planetary culture. This civilization will be slightly more advanced than those currently found on Earth. They will be able to skillfully use the full energy output of their planet. This civilization is thousands of years more advanced than ours. Such a society would be able to harvest, store, and use the energy of its star to meet the energy demands of its growing population. This means that we would need to increase our current energy production by 100,000 times to achieve this status. However, being able to harness the energy of the entire Earth would also mean that we could control all natural forces. So much so that humans could control volcanoes, weather, and even earthquakes. It is hard to believe that such abilities are attainable, but compared to the later types, they remain simple and primitive levels. Type 2, interstellar culture. This civilization can harness the power of all the stars. Not only can it convert starlight into energy, but it can also control the star. The most popular method proposed for this scenario is the Dyson sphere. This device would cover every inch of the star and could collect most of the energy output and transfer it to a planet for storage for later use. Alternatively, the star's fusion power could be used by this civilization as a large-scale reactor to meet its needs. Type 3, galactic culture. Traveling from a planet to a controlled star holds enough expendable energy to make the civilization immune to extinction. It is only when this species subsequently acquires any knowledge of energy and takes its civilization to a galactic level that it transitions to Type 3 and becomes the master race. This civilization can use the energy output of a galaxy. It has about 10 billion times the energy output of a Type 2 civilization and is about 100,000 to 1 million years more advanced than us. They can colonize the galaxy, extract energy from hundreds of millions of stars, travel through interstellar space, and conquer countless planets. For humans, access to such a species means hundreds of thousands of years of evolution, both biologically and mechanically. So there may have been a transformation into a different race than the human race as we know it. These could be cyber or cybernetic organisms, creatures that can be both biological and robotic, meaning that the descendants of ordinary humans would be a subspecies among the highly advanced societies of today. Purely biological humans are likely to be seen by their cybernetic counterparts as defective, inferior, or unevolved. In his scaling, Kardashev did not define beyond Type 3, as it would be too advanced. But later, Michio Kaku, Robert Zubrin, and Carl Sagan, among others, defined beyond Type 3. Type 4, universal culture. This civilization will be an intergalactic culture spanning the universe. They can travel across the universe, commanding the power of trillions of stars. These societies would have superhuman abilities, such as the ability to alter the structure of space-time or the deliberate slowing or reversal of entropy to achieve ultimate immortality, or these civilizations could become capable of living within the event horizon of supermassive black holes. For current humanity, such things seem far, far beyond our reach. Type 5, multicultural. This civilization will have transcended its own universe. It would have the ability to manipulate the scale of the universe, such as jumping between multiple dimensions involving various forms of matter, physics, and space-time. Such a civilization could be home to unimaginable powers and capabilities. So where does humanity currently fall on these scales? Unfortunately, humanity is not currently on any of these scales. We can roughly say that it is just below type 0. We are still using dead animals and plants as energy sources. We are still looking to nature for energy. According to Michio Kaku, it will take 100 to 200 years to reach type 1. The fact that we haven't even reached type 1 yet is, yes, a bit disturbing. Likewise, the fact that we could easily go back to the Stone Age, either through natural disasters or through a catastrophe of our own making. If we want to move beyond a type 0 civilization, the first step is to protect our little home, end wars, and continue to support scientific advances and discoveries. To refresh our knowledge again, the observable universe is about 90 billion light-years across. There are at least 100 billion galaxies, each home to between 100 billion and 1 trillion stars. There are probably trillions and trillions of habitable planets. In short, there are so many possibilities for life to exist and flourish in the universe, right? So where is this life, or as we said at the beginning, where is everybody? Even if extraterrestrial life exists in other galaxies, there seems to be no way to reach them. We may never be able to reach anything outside this local group. There is actually a simple reason for this: the expansion of the universe. Even if we are traveling close to the speed of light, it would take billions of years to reach stars outside the local group. By the time we leave Earth and travel outside the local group, the universe will have already expanded enough to leave us on an endless journey through the empty reaches of space. Okay, let's forget about the universe outside the local group. Let's just focus on our own Milky Way galaxy. There are about 400 billion stars and 20 billion Sun-like stars in the Milky Way galaxy. It is estimated that 1 in 5 of those stars has an Earth-sized planet in the safe habitable zone. In other words, in the area that has the necessary conditions for life to form. If only 0.1% of these planets had life, there would be more than 1 million life-filled planets in the Milky Way galaxy. There is no definitive answer to this paradox, but there is a common theory: the Great Filter. Some theorists accept that the lack of evidence proves that extraterrestrial life does not exist and try to explain why. Other theorists propose ideas about the behavior and technological level of extraterrestrial life and how this great silence can be explained without ruling out the existence of such life. In effect, each of these explanatory hypotheses means changing the value of one or more factors of the Drake equation. These theories are generally not mutually exclusive. For example, the hypothesis that life is rare and the assertion that technologically advanced civilizations are prone to self-destruction can be true at the same time. Consider our best estimate of the evolutionary path that would lead to an explosion that, according to the large filter theory, would lead to the visible colonization of most of the observable universe, the right star system. Something that enables reproduction, simple single-celled life, complex single-celled life, sexual reproduction, multicellular life, tool-using animals with big brains, where we are now, colonization boom. The Great Silence means that one or more of these steps is highly improbable. There is a great filter on the path between simple inanimate matter and exploding life. The vast majority of matter that takes this path does not succeed. In fact, of the billion trillion stars in our past universe, nothing has ever made it all the way through. The fact that our universe is apparently essentially completely lifeless implies that it is very, very unlikely that permanent, explosively evolved life could emerge. Moreover, if there are other radically different paths to pervasive permanent life, this only exacerbates the problem, as it means that the filter on our path must be even greater. One explanation is that human civilization is unique in the galaxy. Parallel to this idea, many theories have been put forward as to why intelligent life should be extremely rare or very short-lived. Many explanations have been developed under the rubric of the Great Filter. Let's look at some of these explanations together. Another civilization never appeared. According to those who believe that extraterrestrial life does not exist, the conditions necessary for life, or at least complex life forms, to flourish are very rare, and even unique to Earth. This view is called the rare Earth hypothesis. Proponents of this hypothesis reject the principle of ordinariness and try to provide a solution to the Fermi Paradox by arguing that Earth is not a typical planet, but an unusual and even unique planet. The idea of a unique Earth has received support from philosophy and religion in the past. The rare Earth hypothesis, however, presents quantifiable and statistical arguments that multicellular life is extremely rare in the universe, because Earth-like planets are already extremely rare, and/or an unusual series of coincidences have combined to allow complex life on Earth. Intelligent life is inherently self-destructive. Technological civilizations are usually or always likely to self-destruct just before or just after they develop radio or space travel technology. The cause of extinction could be nuclear war, biological warfare or accidentally transmitted diseases, nanotechnological destruction, poorly managed physics experiments, a poorly programmed artificial superintelligence, or a Malthusian catastrophe resulting from the deterioration of the planet's ecosphere. Intelligent life, by its very nature, destroys others. It is also possible that intelligent species above a certain technological capacity destroy other intelligent civilizations as soon as they find them. The themes of someone or something destroying all intelligent life in the universe have been frequently explored in science fiction as well as in the scientific literature. A species might attempt such an extermination for expansionist purposes, out of paranoia, or because of its aggressive nature. They exist, but we cannot find the evidence. Even if technological extraterrestrial civilizations exist, humans may not be able to communicate with them due to various filters. Scale or technology issues, aliens inherently trying to communicate in ways we cannot understand, or humanity refusing to see the evidence that exists. Time required. Humanity has not been searching for extraterrestrial life long enough. Humanity may not have existed long enough for it to be found by others. Humanity's ability to find and deal with intelligent extraterrestrial life is a short time. If the discovery of the radio telescope is taken as a milestone, it has been around since 1937. Moreover, Homo sapiens is a very recent species on a geological scale. The entire period of human existence, about 200,000 years, is a very short time on a cosmological scale, while radio broadcasts have only been possible since 1895. So humanity has neither explored long enough to discover another civilization, nor has it existed long enough to be discovered by other civilizations. Physical expansion across the galaxy is very expensive. It is possible that the feasibility and cost of interstellar colonization cannot be fully calculated within current scientific knowledge. Ununderstood theoretical obstacles to such an attempt may arise later, or the cost of materials and energy may be too high for any civilization to afford. Aliens have reached the technological singularity. Another possibility is that technological civilizations are invariably in a state of technological singularity and exhibit a transhuman character. Such theoretical civilizations are composed of individuals so altered that humans cannot communicate with them. Communication with these civilizations that have gone beyond the singularity would require a much greater exchange of information than can be accomplished over interstellar distances. Perhaps they would find any information that humanity could provide so basic that they would decide it was not worth communicating. It would be like humans trying to communicate with ants. They may prefer not to communicate with us. The zoo hypothesis. The belief that alien races would want to communicate with the human species may be a fallacy. That is, aliens may prefer not to communicate with humans, even if they are technically capable of doing so. One possible reason for such a preference is called the zoo hypothesis. Earth could be an isolated zoo or wilderness kept under constant control by aliens. They are not technological. It is not clear whether an intelligent civilization is necessarily technologically advanced. An alien species may not have developed technology because there were no suitable conditions in its environment because it chose not to develop it, or for some other reason. A civilization in this state would be very difficult for humanity to discover. Simulation theory. We may be living in a simulation. If this is the case, other life forms may not be included in the simulation, or our contact with them may be restricted. Perhaps intelligent life forms are included in the simulation, but we may not be able to reach them even inside the simulation for the reasons I mentioned earlier. In addition to all this, there are of course religious and philosophical responses to the issue. According to many traditional views in the Western religious world, humanity is the only intelligent being in the divine creation. Proponents of these views naturally reject the idea that intelligent life could exist on other worlds. There are also conspiracy theories that aliens are already among us, but that they don't want to be recognized or are hidden by governments. To summarize, although extraterrestrial life or intelligent life is very likely, there are just as many obstacles preventing us from detecting them. There is also the fact that by doing so, we may be dooming ourselves. And then one day tomorrow, we might get an alien race that says, "Hello, We received your radio signals, and we've decided to use your bodies as a battery to power our game consoles. I'm Eonvoice. See you in my next video. Take care. Goodbye.